Okay, we're on page 58 of your packet, and we're looking at the 1.6 retrieval and ready, set, go. Go ahead and put your name at the top of each page, today's date, and your period number over here, okay? So here's what they're asking for us first. Predict how the graph of the function will compare to the graph of y equals x. So right here, they're already giving us the graph of y equals x. This is called the parent function or parent graph of all lines. Meaning starting at the origin, it's just going up at a slope of 1. So y equals x starts at the origin. So my y-intercept is 0, 0, and its slope is 1. So now let's go compare what are they asking me for the other function. So for this function, it's y equals x plus 5. So this time I have the same slope, but my starting point, my y-intercept or my b, is different. So this time we would be starting at 5 and then going up 1 over 1, up 1 over 1, up 1 over 1, or down 1, back 1 from there. So check this out. It's technically the graph of a parallel line because it has the same slope. So when it says to compare my graph to the original function, we're going to say same slope, different y-intercept. Same slope, different y-intercept. And so that's what they're asking us to do here, to look at the original parent function and then how is my graph different. So same thing on the next one. Check this out. The original graph of y equals x is already drawn for us. We know that the slope is 1. We know that that starts at the origin. So go look at the new one. Y equals x minus 5. So same as before. This has a slope of 1, but the y-intercept is different. The y-intercept is 0, negative 5. So it's down 5 from my original graph. So this one up here was up 5 from original graph. And now this one's going to be down 5. So this one has the same slope. Okay, and then connect it. You'll notice it's another parallel line because they have the same slope. And so how does it compare? It has the same slope, but different y-intercept from my original. And this one is technically 5 down from the original. Okay, how does negative 5x compare? So again, here's my regular parent graph of y equals x, starting at the origin and going up 1 over 1. So what would negative 5x do? So this one is also going to have the same y-intercept. We're still starting at 0, 0, because the graph of y equals negative 5x, there's nothing at the end. So your y-intercept is still the origin. Okay, so these both start at the same place. Both go through the origin as the y-intercept. Okay, so we know that that's true. But this one has a different slope. The slope, instead of 1, 1, 1, 1, is now down 5 over 1, down 5 over 1, or up 5, back 1, up 5, back 1. So check out how steep this graph is compared to our original. Okay, so what is the same, what is different? Both go through the origin, but the graph of y equals negative 5x has a negative slope that is much steeper than our original graph. It's going down 5/1. Okay, so how'd you do on those graphs? Were you able to see those comparisons okay? Let's go look at this next two that they're asking. Create an explicit function that goes with the recursive, and then create a recursive rule that goes with the explicit. So they're asking you to go forwards and backwards on this. So the first one starts at 12, f of 1 equals 12, and then is going down 3 each time. That's my common difference. So it's linear. So now let's write the explicit. We're going to say f of x equals, begins with 12, subtracting 3 each time to the x minus time 1. Where do all these numbers come from? This 1 goes right here. This 12 starts right here. And this minusing 3 comes from right there. So to be able to go from the recursive to the explicit, how'd you do? Likewise, on this one, I'm giving you, notice that here up in the sky, there's like an x by itself. We know that is x minus 0. That means this is a time 0 function. Keep that in mind. Let's go write the recursive. We'd say f of 0 equals 5. F of x. Oh, did you catch what I did wrong? This one's named g of x this time. Oh, and I just noticed something I did wrong on the one above too. Anyways, create a recursive rule that represents g of x equals this. So g of x minus 1, this one happens to be multiplying by 2. So where do all these numbers come from? We've got the rate of change happening right here. We've got the time 0 from the fact that there was no number given there. And then we see that starting point of 5 from right here. Begins with 5. Okay, what did I do wrong on the other one? Well, technically, do you see how it says function right here? When we say function, we should be using f of x to designate a function. So the fact that they said f of n right here, I would take either answer if you wrote f of n equals this or if you wrote f of x. But when we're talking about functions, I really do want you using f of x. So keep that in mind. Okay, the ready is now going to have us practice what we just did in the retrieval. See how there's 1, 2 graphs, and then we go into the set. But so here it is practicing the comparison of graphs like we just did. Go ahead and put your name at the top. There's only 2 questions here on the ready. Put the date and the period. So graph the following linear equations on the grid. The equation y equals x has already been graphed on there. There's our parent function of y equals x. For your new equation, explain what the number 3 does to the graph. So what's it doing here, what's it doing here, and what's it doing here? Okay, so let's go graph these. Here my slope is 1. My y-intercept, my b, is 0, 3. Here my slope is still 1. My y-intercept is negative 3 this time. Finally, my slope is 3, and my y-intercept is the origin. There's no number here at the end, so it's just going through 0. So let's go graph these. I'm going to use those associated colors, starting at 0, 3, 1, 2, 3. And then this is the purple one, going up 1, over 1, up 1, over 1, etc. And then go ahead and connect that line. So notice what happened for purple is it moved the graph up 3. So what did the plus 3 do in A? It moved the graph up 3. Let's go graph the second one. Begins at negative 3. Up 1 over 1, up 1 over 1, etc. Down 1, back 1. Go ahead and connect that graph. And you're noticing that you're getting another parallel line. But this one for B, it moved the graph down 3 from the original place. So this x minus 3 moved it down 3. Finally, part C. This one starts at the origin, And the slope, instead of going up 1 over 1, is now going to go up 3 over 1, up 3 over 1, and down 3, back 1. This is going to create a much steeper graph than our original parent. So what did that do? The change in slope created a steeper graph. Pause the video now and go try number 2, and then let's check out to see how you did. Okay, the graph of y equals x, our parent function, is given again. And we're making a prediction this time. I think this is going to move the graph where? What did you say? Good. Down 2. This time it's x minus a negative 2, which means plus 2. Did you guess it would move it up? And finally, this would make our graph steeper and a negative slope, which means it's going to be going down instead of up this time. Let's go graph them and see. First one begins at negative 2. So A has the same slope of 1, but a y-intercept of negative 2. Okay. B it simplifies to x plus 2. So this is going to have a slope of 1 and a y-intercept of positive 2. So this one moves it up, and then up 1 over 1. Okay. And then finally, part C is asking us to do negative 2x. So it starts here at the origin and goes down 2 over 1, down 2 over 1, down 2 over 1, or up 2 back 1. So you're noticing not only did the slope change, it's now a negative slope, but it's much steeper than our original graph. Okay, and so this one had a slope of negative 2, and it goes through the origin. All right, how'd you do? Did your predictions work out over here? I hope you're starting to get a feel for how those numbers change your graph.